All right, guys, today we have a cross-curricular lesson. We're going to be doing art and math with Miss Lee and Miss Kay. Okay, what is the art lesson for today, Miss Lee?
I think we're gonna draw our favorite character. We're gonna do our Baymax.
All right, sounds good. I'm ready.
Okay, so Baymax has a small head, a really big body, and mushy arms and legs.
Okay.
Got it?
Yeah.
Okay, now.
And then, I can afterwards, that's when I'll start, I'll bring that in a little bit. Just a little bit on both sides.
Okay, next, the body. Wait, the thing that every artist has to do, this is what I always say in class. Guys, the last thing we always do to make sure that no one else can take credit for our work is to sign it.
All right, guys, we're actually going to continue our art in today's lesson. As we move into chapter 11, which our focus is going to be called radicals, we are going to be starting with graphing. So it does tie into art. So go ahead and take out your notebooks, and then let's go ahead and take some notes on what a radical graph looks like. All right, guys, so if you're still keeping up in our table of contents, we're going to add 11.1, which is graphing radicals. All right, and so radicals might be a new word to some of you guys. So I'm going to go ahead and write that down as kind of some vocab that we have. So radical expressions. They're going to be expressions or problems that actually contain a square root in them. And so we've seen a lot of square roots, especially when we're solving our quadratics, be it with that square root method or completing the square. So again, radical expressions are expressions or problems that contain a square root, or again, what's called a radical, in the problem. And so again, another word for this would be our square roots. All right, so what we're going to be doing this chapter is actually going to be solving problems similar to what we did with our square root method. We're also going to be simplifying them, and then we'll start with a graph those, just so you kind of have an idea of what these problems look like if we were to graph them. All right, so the first thing that you guys need to know is that our graph of y is equal to the square root of x. This is known as your parent function, so you might see this word parent function in your book. And what that just means is, what does the basic graph of this look like? And so let me go ahead and pull up a graph for you guys. All right, like any good graph that we do in our class, you guys will be making a table today. And so I will show you guys what that looks like. So think about the problem though here. So here is our problem. We are going to be plugging in numbers into x, which is right here underneath that square root sign. And one thing that we focused a lot on in chapter 10 was that we could not take the square root of a negative number. We said that there was no solution, that it wasn't possible. So it's not going to actually make sense for me to plug in -1, because think about the problem. Y equals the square root of x. Y is equal to the square root of -1 is not going to work here. So I'm not going to put any negatives there. Where I'm going to start my table is actually at 0, because that's actually a number that I can plug in. I know that the square root of 0 is still 0. All right, typically we're going to plug in numbers like 1, 2, 3, and so on. So what I might actually suggest though is using numbers like 4, because we know that the square root of 4 is 2. We know that the square root of 9 is 3. So without having to pull out that calculator, I can get some quick numbers. So let's go ahead and fill that in, and let's go ahead and take a look at what that graph would look like though. So 0, 0 would be that origin point. 4, 2 is going to be right here. And then 9, 3 is going to be right here. And hopefully what you notice is that these 3 dots are not a straight line. So it's not linear, because again, what we're focusing on is on a radical. Radical is actually going to give you this kind of curve shape here. What I'm going to point out are a couple things about this graph though, is that right here in the center point, you are going to make sure that there's a dot there. So it does not have arrows in both directions. It's only continuing this way to the right. So it's growing this way. We're going to put that arrow on the end here to indicate that it would extend further. But again, you're going to get this kind of ray-like shape. So it has a little bit of a curve to it, but again, it has an end point, and then it has an arrow extending it in the other direction. And so all of our graphs today are going to have that same kind of shape, and that's what you're going to be looking for as you graph. All right, so let's try a couple different ones. I want to show you the role that different numbers play onto your graph. So I'm going to go ahead and move this up. All right, here is what our problems are going to take the form of. Y is equal to a rad x, and you're going to notice that we start calling the square root rad for radical, so rad x. And then sometimes we might see underneath that radical sign, it might look like this, plus h and then plus k. So we're going to talk about what the number in front does to our equation. We're going to talk about what the number underneath does to our equation and graph. And then we're going to talk about what the number, if it's outside of the radical and it's being added on, how that changes it too. So I'm going to show you guys some examples. Don't worry, I will graph most of them. But again, I'm going to show you how those different numbers play and affect our graph. All right, so let's take a look at this. Let's say we have y is equal to, let's do negative 0.5 rad x. And what this means is negative 0.5 times x, because it's right next to that radical. So just like if we saw something like this, we know that that's 5x. This just means that it's being multiplied. Negative 0.5 times rad x, so it's being multiplied. All right, so same idea here. What I'm gonna ask you guys to do on your homework is your favorite. It is to make a table for me. I am gonna ask you to plug in some points. I'm gonna say that you need about 4 points though. You do wanna start to get that curve of that arch going. So that is where I would tell you to start by, is getting in at least 4 points there. And you can do all calculator work, so do not worry about having to set that up and show me anything like that. Use your calculator. Okay, so just like we saw before, we can't take the square root of a negative. So it's not going to make any sense to plug in a negative there. And so I am going to start here at 0 again. I'm going to just go ahead and use, let's do 0, 1, 2, and 3. All right, and it's going to be the same concept. So what's happening is you are going to take your number and then plug it in. So this would be negative 0.5 times the square root of 0. Okay, 0. And then you would do the same from 1. Negative 0.5 times the square root of 1, and then so on. So you don't have to sit there though. I will go ahead and give you guys these numbers. When you do that, you end up getting negative 0.5 here. You end up getting negative 0.7, and then you end up getting negative 0.9. All All right, so same idea. You're gonna go ahead and graph that. All right, on this graph, it's gonna be hard just because my graph is counting by ones, but I'm gonna go ahead and do my best to graph that for you guys. So then this would be about half here, here, and then at 3, it's almost at 1, so we'll make it like that. All right, so again, you'll notice that we start to get that kind of curve shape like that. And it's okay if it's not exact, but again, notice that that square root sign gives you that curve shape. Now, why I gave you this problem is because what I want to point out to you is notice where it's located though. That parent function that we graphed here was located above. So right here, above that x-axis. But because there is a negative in our graph as the leading coefficient in front right there, that negative is reflecting it so that it's down here. So again, a negative graph is always going to be on the bottom side. So again, for example, what I mean by that is if it's a positive graph, that graph is going to start here and it's going to be curved on top. But just like we saw in that last example, if it is a negative, and you can tell because it has the negative in the front, that graph is going to start here and it's actually going to curve on the bottom part like we just saw. So that's what that first term does. So the first term actually indicates how wide that graph is. So if you also notice here, this 0.5 is going to make it a little bit more narrow versus maybe something that might be graphed and might be a little bit wider like that. So it changes how wide our curve is going to be. But again, the big thing here is just take a look and see, is it a positive or a negative graph? And that should kind of indicate where your graph will be located. All right. Next example, let's say we have something like this. Y is equal to the square root of x plus 3. All right, so on this graph this time, what's different is that we have a term that's going to be either added or subtracted. Please notice that it is not underneath the square root. So it is not underneath the square root. And that's going to be important as we plug in numbers. So same idea. Let's go ahead and plot this one together. All right, so same idea. Make the table for me, guys. And again, just think about where you're starting. We know that we are taking the square root of x. So again, not going to make sense to put in any negative numbers. The first number that you'll actually be able to solve for is going to be 0. So we will start again at 0. And then, like I said, I would probably just use our 1, 2, and 3. So I am looking for at least 4 points. And again, same idea. You're going to go ahead and plug in those numbers. For example, this would be the square root of 3. Calculate it. Do not leave it as a square root of 3. I want the decimal number, and then you would add 3 to that. So I'll give you guys a second if you're following along to fill in that table, and then if not, I'm going to go ahead and fill it in too. All right, guys, so we'll go ahead and fill this in. When you fill this in, what you end up getting is 4.73. When you plug in 2, you end up getting 4.41. When you plug in 1, you end up getting 4. And then when you plug in 0, you end up getting 3. So let's go ahead and graph that now. So 0, 3 is going to start right here. 1, 4. 2 and 4.4 is a little bit under half. And then 3 is at 4.7. So something like that. But again, what you should notice is you do get that curved shape, kind of like I have here. And then we're going to put that arrow on it. So again, that is our radical graph. Now, what I want to point out to you, though, is how this 3 that's on the outside changed our graph. Do you guys have any ideas? Hopefully, you said, oh, it shifted the graph, because you would be right. Notice where the starting point of this graph is. It's located 3 points up, which coincidentally is plus 3 here. And so anytime that you have a number that is on the outside, so not underneath that radical, what's happening is it's actually going to shift your graph. So this shifts the graph up or down, and I'll move it so you can read it. So because it is a +3, it's shifted over 1, 2, 3 up, just like that. All right, let's take a look at a couple other examples, and then I think you guys will be good to go. All right, let's take a look at a problem like this. Y is equal to the square root of x minus 4. Perfect. All right, so same idea. We want to make that table. All right, so notice the difference on this problem though is we have a number that is underneath the radical sign. So let's go ahead though and let's think about how that is going to change our starting point. So for example, we've been starting all of our problems at 0. Okay, think about if I plugged in 0 here. 0 minus 4 is -4. I can't take the square root of that. So because that number is underneath the square root, it actually changes our starting point. So that's going to be something to consider. So we actually want to watch out for that. This is actually what you need to do, is to find the starting point for any radical graph. So to find starting point. What you're going to do is you're going to take what is underneath the square root and set it equal to 0. X minus 4 is equal to 0. X is equal to +4. So the square root of +4 minus 4. So think of it as if there was an invisible parenthesis there. So 4 minus 4 is 0. The square root of 0 is 0. And so there's that 0 kind of as that starting point. So again, the first thing that you always want to do with a radical problem is set it equal to 0, whatever is underneath the radical sign. That is going to give you your starting point. So like we saw here, this 0 is no longer the starting point. The starting point, like we saw, is 4. So 4 is our starting point. And then I would go 5, 6, and 7. So again, remember, set that equal to 0. All right, so same thing, we're going to plug in those numbers. All right, for sake of time, I'm giving you the answers. But if I were to graph this then, so 4, 0, 5, 1, 6 and 1.4, and then 7 and 1.2. So we get that kind of same curve. The difference of this graph though is it is starting at 4 though versus starting at 0. And so hopefully what you're noticing is it's shifted again. But unlike this problem, we saw that it shifted up and down. Hopefully this time what you'll notice is this one shifts left and right. So anytime that your number right here is underneath the radical, you are going to have a shift either left or right. Do you guys actually notice the relationship here? Even though this is a -4 here, notice that this one shifted over 1, 2, 3, 4 to the right. What do you guys think it's going to be if it was a, let's say, +4? If I had maybe something like this. Let's use a different color though. Y is equal to the square root of x plus 4. There you go. How do you guys think that would shift? Hopefully you said that it would shift to the left. So it's always backwards. So the same idea is that you would set this equal to 0. -4. So that would actually be your starting point. So a graph like this would actually shift over to your left instead from 0. So that's what's happening when it's underneath the radical sign. All right, we're going to take a look at one final example and then we are going to call it a day. All right, so this is the form again of our radical graph. At the beginning, I actually had this as a plus, but you'll see it as a plus or minus just to indicate that. So again, what I want to remind you is this, is that the A here just determines if it's positive or negative, and it also determines how wide or how narrow your graph is. So this is positive or negative, and then this is how kind of wide or how narrow your graph might be. All right. In our second example, we looked at what happens when the number is outside of the radical sign. And remember, what's happening here is this shifts your graph up or down. So up or down by how many spaces or how many numbers. And then the last example we just looked at is this whole term here. Is again, if that is underneath the radical, this shifts left or right. All right, and then the last thing that I just want to remind you guys though of is that when we graph, we always set the radical. So whatever is underneath that square root equal to 0 to find our starting point. All right, and so those are the steps that you guys are going to be taking to graph. So I'm actually going to let you guys try this last example. I will show you the final answer, but go ahead and try it as well. So I'm going to go ahead and scroll this up, and your final problem is actually going to have all of these different terms on it. So what I'm going to have you guys graph is this. Graph for me, y is equal to 2 times x plus 4. And then let's do minus 1 here. So we can see what all the different changes to the graph are. All right, so go ahead and start. See if you can find out what that starting point is, and then see if you can get that curved shape. All right, guys, we're back. Let's see how you guys did. So first thing again is to set whatever is underneath this radical here to 0. That helps you find the starting point. So your starting point here would have been -4. Now, really quickly before I speed up this video, I want to just point out when you are solving and you're plugging in the numbers, this is what it would look like. For example, if I was plugging in -4, I would have y is equal to 2 times the square root of -4 plus 4, and then minus 1. All right, when you simplify a problem like this, start with the radical first. So start with the square root. Pretend though that there are parentheses here and simplify that first. So this would become 2 times the square root of 0 and then minus 1. Now, as you guys are using order of operations, square root actually falls under exponents because, fun fact, the square root of x is actually the same thing as having a 1/2 exponent. So a square root is actually an exponent. So that is part of PEMDAS, or the E of PEMDAS. So you would do exponents next. So in this case, this would be equal to 2 times the square root of 0 is 0, and then minus 1. So 0 minus 1 is going to be equal to -1. So that would be our first answer. All right, guys, and then I'm going to show you one more time how we plug in that number. So again, what's happening here is this would be 2 times the square root of -1 plus 4, and then minus 1 at the end. Remember, when you are simplifying this, though, you simplify what is underneath the radical. So pretend like that parenthesis set is there. Simplify that first. So this would be 2 times the square root of 3, and then minus 1. Remember, like I told you, that exponents come first. So remember, square root is an exponent, so you're going to simplify that. So you're going to take 3 and square root that. So this would be 2 times the square root of 3, which is 1.73, and then minus 1. And then again, following order of operations, 2 times that, 1.73, and then subtract 1 from that. So this would be 3.46 minus 1. And then here you would end up getting 2.46. All right, so again, just be very cautious with that, especially as you're plugging in numbers. Now, before we graph this, I'm just going to point out right here, when we are taking the square root, this time we are only going to be taking the positive square root. So I know we talked a lot about that plus minus. You do not need that minus here. We are only talking about the positive values here. All right, guys, as you guys plot that, this is what your graph should look like. So again, you'll have your starting point at -4. So let's talk about just again the different things that we can notice here. So parent function was that first one we graphed, and I'll remind you. It looked like this guy, which was actually this graph. 1 and 2. So here's our parent function. So again, I'm just going to show you really quickly what these different roles do. So that -1 that we graphed here, what you should notice is that that graph actually shifted down 1. So right here, I'm going to move my cursor. It's going down 1 right here. All right, that +4 here, remember we talked about how it was the opposite in movement. That shifts our graph to the left 4, and you'll notice here, instead of starting at 0, we're shifting over 1, 2, 3, 4. So here at this -4. All right, this is a positive graph here, and we can see that because of this 2, that leading coefficient here is positive. So it is going to be upwards like we saw. But what I also want to point out to you, though, is we talked about that, how wide or how narrow that graph is. Look when we did 0.5, that graph was a lot more narrow. It didn't have more of a curve. It's more flat, which is the opposite that we're seeing here. So it's very minimal, but you can tell that this curve is a little bit more flat versus this one is going to be a little bit more wider. And so that 2 is making it wider. And so that's how it's playing there. Now, the last thing we're going to say is this. You are going to come to a point on your homework where it is going to ask you to identify, again, domain and range. And so we saw this previously. Domain, remember, is talking about your x values. What are the x values that this graph can be? And then range is talking about your y values. What are the y values that this graph can be? And so this is what I will point out to you guys as you guys are doing this. So you're actually going to be using inequalities to describe this. For example, if I'm looking at this graph here, the domain, the x values. So remember, x values are left to right. This graph is starting here at, on the x value, -4. But then think about which way it's moving. It's moving to the right. So it's everything on the right of that. It's everything here. Everything that is bigger or greater than that starting point at x. So you would say that your domain is x is greater than or equal to, because it is at -4. So at -4. So really quickly, let's try that with, let's say, this graph here. If I was looking for the domain here, so again, think about x's. So this graph on the x is starting here at 0, and it's moving to the right. So it's everything that is greater than or equal to 0. So x is greater than or equal to 0. So you just figure out, where does it start on your x's? And then is it greater than? And it should be. So it's going to be greater than or equal to that value. All right. Range we know is the y value. So same idea here. Take a look at where your graph starts on the y's. So our graph starts here, and that is at -1. And again, the graph is going upwards. So it's -1, 0. So it's everything greater than. So you're going to say the same thing, that your range is greater than or equal to -1. All right. Just to give you guys one last example. Let's say your range on this graph, then same idea. Look at where it starts. Here's our y-axis right here. Oh, this one starts here at 3. And again, it's everything above it. The graph is above 3. So you're going to say that range is y is greater than or equal to 3. Where you might see that different is actually that second one here. So let's do last example. Domain here and range. All right, so domain we know is x. So start on the x's. This one starts here at 0. And our graph is moving to the right. It's everything that is bigger than 0. So greater than or equal to 0. Range is y. So we're going to start with y. Your y is here at 0. But notice this time your graph is down here. It's going to -1. It's going to eventually hit -2, -3. So it's lower. It's less than 0. Less than or equal to 0. So that's how you're going to fill in that domain and range. But what I'm going to be checking for is that you guys get those curved shapes and that you have a table.
Perfect. Bye. See ya.